Hello everyone, welcome back. So in this video is how to create the ladder logic using the RSLogix 500. So as you can see, so I already created the sum of ladder logic. So nakita nyo po sa screen na so at first I created first the input configuration. So as you can see in this row, the first row 1 to 15, or there are 15 inputs. So I designate, or I created every numbers. Let's say input 1, input 2, input 3, until input 15 or 16 rather. So as you can see, this is, and then click this arrow and then the output configuration also. So in this row, the last row, I created the output. So I designate output 1, output 2 until output 6. So as you can see, okay, so as you can see, I created first the NOT gate. So in NOT gate, I use the normally closed switch and then output, then AND gate. So the AND gate, there are two series normally open switch, as you can see. Then I use the input 1 or input 2, and then the third is I created the OR gate. This is the two of normally open parallel switch, as you can see, and then output. And next I created the NAND gate. So in NAND gate, the two normally closed parallel switch, as you can see, and then output. The next, I created the NOR gate. So as you can see, the NOR gate is two normally closed connected in series. And then, as you can see, I made the output. Okay. This is NOR gate. Two normally closed connected in series. Next, so let's create another gates. So click a new rung, and then drag the normally open switch. Again, another normally open switch in series, and then click the rung branch, and then drag to the right, and then click the two normally closed switch in series. So this is series parallel, and then click the output and then drag to the right. So ganyan lang po ang paggawa ng output. So pag mag-appear sa una, so drag it to the right. Then let's make the input rather. Let's assign the input. So this is okay. There is already a label, numbering of inputs. Then drag and then release. Okay. The next, create the output. So I already designated the output. So this is the output. Drag it here. Okay. And then next, let's make the run comment. So let's say this is XNOR gate. So this is the XNOR gate. So then, so we created already the 6th gates, and then let's create the last gates, the 7 gates. So you click the new run, and then drag the switch icon. So to normally open, connected in series, and then create a new run branch, and then output. So in this gates, one normally open and then one normally close, connected in series, and then connected in parallel, one normally open, one normally close. So and then I created the input, configuration, and output. Okay. Then output this. Okay. So finally, we completed the ladder logic. So this is the SOR gate. So the last is the SOR gate. So from NOT gate until to SOR gate. Okay. It's done. Our 7. So let's download, and then run the ladder logics. Okay. Let's test one by one. So in NOR gate, toggle bit. So as you can see, the output, it's on. Then toggle bit again, it's off. And then AND gate, toggle bit, it's off. And then to switch on, and then the output is on. Okay. Next, OR gate. So even one switch is on, the output is on. Okay. NAND gate. So it's already on because normally closed. So toggle bit. So if one is on, the output is on. Then so next, NOR gate, toggle bit. So toggle bit the second switch. So it should be to normally close switch on, and then output is on. Okay. Next, XNOR. So if we're going to toggle bit, this is okay. Toggle bit. So if the first switch is off, so the output is off. Even the 3 switch is on. Okay. So it should be complete. Okay. So last, the SOR gate. So the same. Toggle bit, the first switch, it's on, so it should be completed. So toggle bit, the second switch off, so it's off, the output is off. So as you can see, just follow the toggle bit on and toggle bit off. So also the first switch is off, the output is off, and then the 2 switch is on, toggle bit, okay. So just follow how I toggle bit. This is the SOR gate. So our ladder logic is done. So thank you. Go offline. Okay, so it's done. Our ladder logic rather.